Hello students, let's start with another revision capsule for the integrals chapters. Okay, so here this question is given to us x square plus 1 divided by x square plus 2 bracket x square plus 3. So here I will consider that x square is equals to y first and can convert this photo into kind of like this. Let x square is equals to y, so here it will become y plus 1, y plus 2, y plus 3. This is how it will be. So here now you can change it as y plus 1, y plus 2, y plus 3. Partial fraction method I'm applying. Y plus 2 b, y plus 3 it will be. So comparing the coefficients of the numerator a y plus 3, b y plus 2. When you solve it, put y is equals to minus 2. How come minus 2? Here you will put 0, you will get minus 2, minus 3. That is how you will get. And minus y is equals to minus 3, you will get a is equals to minus 1, b is equals to 2. I hope that much you have understood it all. Please pause the video and first try to solve it by your own. Now, after you have to insert this value to the mainframe like y plus 1, y plus 2, y plus 3 is equals to minus 1, y plus 2, y plus 3 it will be. So once you do the integration part now, so y plus 2 dx, y plus 3 dx, you will get your answer minus 1 upon root 2 tan inverse x by root 2 plus 2y root 3 tan inverse x y root 3 plus c. This will be your final answer. Here y plus 1 plus. I hope you enjoy the session. Okay, next question. If I wrote it down, x square plus 3x plus 2 dx it is. How would you like to solve this one? Again, let the numerator part we have to create now. So I will create in terms of the differentiation of the denominator. The differentiation of the denominator should be present in the numerator part. So once I solve it up, what will I get? 2x plus 3a plus b is equals to 2ax plus 3a plus b. All the constants are at one side. 2a is equals to 1 and 3a plus b is equals to 0. So a is equals to 1 by 2 and b is equals to minus 3 by 2 I'm getting. So how will you solve it now? This is your I. So I will become kind of like 1 by 2, 2x plus 3, x square plus 3x plus 2 dx minus 3 by 2 dx. This is how it is. So I becomes 1 by 2 I1 minus 3 by 2 I2. This should be a little longer term now. Lengthier solution it will be. So first, how will you resolve the I1? 2x plus 3 x square plus 3x plus 2 dx. And this is simply case or this is simply log. This clearly you can assume it as t and differentiation is there. So log plus this would be the answer for I1. Okay. For I2, 3x plus 2 you can make it a perfect square. 2 whole square plus 2 minus 9 by 4 it will be. Once you solve it, you will get x plus 3 by 2 whole square minus 1 by 2 square. Once you solve it up, 1 upon 2a log, I should write it down over here. 2a log x plus 3 by 2 minus 1 by 2, 2 plus 1 by 2. This is how it would be. You will solve it more and you will get your answer kind of like this. This would be your answer. Okay. So at the end, how you will manage it out? I is equals to half log x square plus 3x plus 2 minus 3 by 2 log plus c. This should be your answer. Okay, next question. Sec square x, tan square x plus 4 it is. So how would you like to solve this question now, sir? Here we can put tan x is equal to t. So you will get sec square x dx equal to dt. Okay. So in this x square x t square plus 4 dt upon sec square x, we will cancel it out. Only this will remain under t square plus 4. Once you solve it, you will get log. I have used over this formula like dx upon under root x square plus a square, which will be log x plus under root x square plus a square. You have to show your examiner this is the formula you are using it up. Okay. Kindly solve it by your own. Pause the video and then try to resolve it. Then see the solutions if you're not getting it. Okay. Let's do some more sums. Integration of under root 1 minus sine 2x dx. This is an easy problem. Everyone can solve it on. Like 1 you can write it down. Sine square plus cos square is 2 sine x cos x. I've used the shortcut. So here this will become under root sine minus cos to the whole square. So integration you have to do basically sine minus cos dx. So sine minus cos you will get minus cos x. This will be your answer. Okay. Alrighty. Integration of tan square x sec square x divided by 1 minus tan to the power 6x dx. How do you like to solve this one? So for this, let's put tan to the power cube x as t, because here tan square is given, na, that's why. So 3 tan square x square x dx is equal to dt. I will get dt by 3 here it will become, so 1 upon 3 upon t square 1 upon 3. When you solve it, log 1 plus t 1 minus t plus c. This is how you will get your answer, sir. You can further solve it. 1 upon 6 1 minus t plus c. When you put down the values, you will get your answer as I is equal to 1 upon 6 log. Substitute the values, and this is what you will get in the end. Okay. Let's do another one. Integration of sine x log cos x dx. So here we can put cos x as t, sir, minus sine x dx is equal to dt. Once you do this integration of log t dt, apply the integration by parts. Differentiation of dt log t integration of 1 dt dt here it is. So once you solve more and more, I will do the steps over here. Minus integration of log t t 1 upon t dt. T to t gets cancelled out. T log t here to minus t. So just substitute the value. T is was cos x log cos x minus cos x, minus and minus will become over here to become plus. This will be my final answer. Good question it is, although. Let's solve more. 3 minus 2x minus x squared dx. First make the coefficient of x squared as plus. Then try to make the perfect square. Now put x plus 1 as t, you will get dx is equals to dt. 4 2 will become 2 square minus t square dt now. So once you solve it up, you will get your answer as 1 by 2 t under root 2 square minus t square sine inverse t by 2. Which formula I have applied? Integration of under root a square minus x square dx, which you can remember 1 by 2 x under root a square minus x square plus a square sine inverse x by a. This formula I have applied it here. So your final answer will become 1 upon 2 x plus 1, 2x minus x squared sine inverse by 2 plus c. This will be your answer. I hope you are able to understand the solutions. The questions are a little lengthy this time, the capsule revision 2. Sine cube x, cos cube x. This we have done already before in the part 1 now, so yeah, let's wrap this up. X minus 3, x minus 1 cube, e to the power x dx. So how we will solve this? E to the power x minus 1 minus 2 here dx, here it is. E to the power x it is, so you have to keep in mind that formula. Take the LCM, x minus 1 to the cube dx, here it is. Here e to the power x 1 upon x minus 1 whole square 2 upon. Now I will apply this formula, e to the power x f of x plus f dash of x dx is equal to e to the power x f of x. So my crystal clear answer here would be x square plus c. This would be my final answer. Okay. Let's do some more. E to the power x 1 plus sine 2x. Let it be kind of like this. 1 plus cos 2x. This would be a sum. So e to the power x sine square x plus cos square 2 sine x cos x. This is how it will be. So here I can apply e to the power x. Here this will become sine plus cos square and under root will cancel out, and here in the denominator 2 cos square x will be there. So 1 by 2 I have taken it out. Take the LCM sine x cos square x plus cos x. Here it will be 1 upon cos x only. So once you solve it up from here, you will get 1 upon 2 e to the power x sec x tan x plus sec x dx. So your final answer will become e to the power x by 2 sec x plus c. This will be your answer. Okay. Another question is e to the power x or 2x minus 4 e to the power x minus 5 dt. So here you can put e to the power x as t. You will get the same dx as dt. So dt under root 40 plus minus 5, sorry, minus 5 I will get log t minus 2 plus, see here you can write it down like this as, make the perfect square, no sir, so that will become, okay, so minus 3 square it will be. So just substitute the values at the end now. You will get your answer. Okay. So this would be a question. Alright, sir. Remaining questions, anything else in the DPP part which you have to do? Please look at the solutions and tell me if you have any more doubts. Let's do a little more sum of integration of 1 upon cos. This is a very tailor-made problem actually. Here you have to keep in mind cos is there, so you will multiply divided by sine a minus b. Cos x minus b is 1 upon sine a minus b cos x minus a sine x minus b. Here, now sine, wait a second, sine a minus b I would like to write as x minus b. This is how I would like to write. So 1 upon sine a minus b, then I will use the formula sine a cos b minus cos a sine b. Sine a cos b cos a sine b. So once I solve this thing out, sine, take the LCM part, tan x minus a will remain. Only this much will remain, everything will cancel that. So once I resolve this, I will get my answer as 1 upon sine a minus b bracket minus log cos x minus a x minus b. It is sine a minus b log cos x minus b. This would be your final answer, sir. Please see this. Yeah, quite lengthy although, but yeah, this is how it will be done. 1 plus x squared dx. How you will resolve this? Consider put a 1 minus x plus bx plus c 1 plus x square. Okay, this is how it will be because the differentiation of this will be in terms of x, so bx plus c. Take the LCM part, sir, using the partial factors method I am doing. 1 minus x 1 plus x square. Bx square plus c minus cx. On equating the coefficients of the constant term, you will get a plus c is equal to 2 to 0. This is equation number 1, equation number 2, equation number 3 it is. Once you solve them all, you will get a is equals to 1, b is equals to 1, c is equals to 1. This is how it would be. So here I equals to x plus 2x plus 1 dx, 2x plus 1 x square minus 1 dx. Now resolving 2x plus 1 x square minus 1, again here you again have to apply the this I will to again solve it into a upon x minus 1 plus b upon x plus 1. Again when you compare that, take the LCM plus b x minus 1. So you will get a plus b as 2. This you are getting. So basically you can convert it into kind of like this. Overall my answer in the end would become kind of like this: integration of x dx I 3 by 2 1 upon x minus 1 dx This would be my final answer. That's what I have to integrate it now. I will become x square by 2 log x minus 1 plus 1 upon 2 log x square by 2 1 upon 2 log plus 3 outers. This will be our final answer. I hope you enjoy our session. We have done a lot of good numericals today, lengthy ones. Thank you so much.